The third way of making magnets, another way of magnetizing a magnet is by induction. Now, when you bring a magnetic material like iron, steel, you see this diagram. If this is a magnet, it has north and south. Then you bring a magnetic material. It can be steel, a steel bar, it can be iron bar. Immediately you bring it near, what happens? It gets attracted by a magnet. Why? Because it is a magnetic material. One time we said magnetic materials are those which are easily attracted by a magnet. Now, once you bring iron bar or steel bar near the bar magnet, it gets attracted. But after getting attracted, the steel bar or the iron bar also becomes a magnet. So the first thing is it gets attracted, and secondly, it becomes magnetized. So if it becomes a magnet, it means one side will become also north and one side will become south. Now the question is, which side becomes north and which side becomes what? South. Now, it will depend on the pole of the magnet. If you brought this steel bar or iron bar near the south pole of the magnet, automatically this one becomes what? North. Why does it become north? Remember, these two are now attracted, and if they are attracted, then they must be like poles. I mean unlike poles, because if they are like poles, they would repel, but because they are attracting, they must be unlike poles. If this is south, this one becomes what? North. If this was north, this one would become what? South. Because it is south, this one becomes north, and automatically this one also becomes a south. So putting it in writing, we say a steel bar, see the first statement here, a steel bar is brought near a magnet. Now we are not saying only steel bar, it could be a steel bar you are bringing or iron what? Bar. You bring it near the magnet. After that, what do you observe? The bar magnet is attracted. I mean the bar, that is the steel bar. We have two bars here. There is a steel bar, then there is a bar magnet. So to differentiate, this one is the steel bar. The steel bar is attracted to the magnet, and then it becomes magnetized. It becomes a magnet itself. So this is an observation. It gets attracted, and then it becomes what? Magnetized. So when you are describing this, this is where you earn yourself what? Marks. The first statement is you bring the steel bar near the magnet. The second one, you tell us what happens. You will see the steel bar being attracted, and then it becomes a magnet. It becomes magnetized. So this type of magnetism, we have said this bar magnet gives magnetism to the steel bar. So the steel bar is attracted, and then secondly, it is magnetized. So one side becomes north, one side becomes what? South. Now, research has shown that should you remove this bar magnet and you leave this steel bar alone, you realize that the steel bar also loses magnetism. So once the bar magnet is removed, the steel bar also loses what? Magnetism, which means, that is our next statement, the type of magnetism which the steel bar acquires is called induced magnetism. It is temporal. It is induced magnetism, and we are putting it here in writing to emphasize. Note that on removing the bar magnet, the steel bar loses the magnetism. What does that mean? It means the magnetism which it had acquired is temporal, not permanent. Now, there is another question related to that. Question number 2A, Roman 1. It says, with the aid of a labeled diagram, explain the term magnetic chain. I want to explain this. You could even do this at home. If you bring a bar magnet and then you get a piece of nail, iron nail. These are all iron nails. How many are there? There's one, there's two, there are three of them. So if you bring an iron nail, because this is made out of iron, you see, we are saying these are iron nails. It is made out of iron, and iron is a magnetic material. So what happens to the nail? The nail will be attracted to the magnet. And once it is attracted, one side of the nail becomes north, one side becomes what? South, depending on the pole of the magnet which you have brought the nail near. If it is a south, this part becomes north, then the downer part becomes what? South. should you bring another nail towards this nail, this nail also will attract this. Once the first nail attracts the second one, it means the first nail is a magnet. So it can attract another magnetic material. So remember, this was north, this is south. So when this one gets attracted to the first one, it also becomes a magnet, ready to attract another one. And therefore, this part becomes the north. Why does it become north? Because this is what? South. Remember, for them to attract, they must have opposite poles. So if this is south, this one becomes the north. And the downer part becomes the south. When you bring another iron nail, the story continues. It is again what? Attracted. So we are saying these three, these are iron nails. You see? The iron nails become induced magnets. They become temporary magnets called induced magnets. So they can also attract more. So the more you bring the nails, the more they will be attracted. So you end up with a chain of nails. And that is what we call a magnetic chain. So putting it in writing, we are saying when an iron nail is brought near a magnet, the first thing is it is attracted. You see where the tick is? It is attracted to the magnet. After being attracted, it also becomes a magnet. So it becomes magnetized. And that process is what we call induction. Now, the induced magnetism causes a magnetic chain. This magnetism which the iron nail has received will keep on attracting other more iron nails brought. So you end up with a chain of nails. That's why we are saying the induced magnetism causes a magnetic chain, where each nail added to the chain magnetizes the next one by induction. So as you bring more nails, the second nail near the first one, it also gets attracted. The third nail near the second one, it also gets what? Attracted. That means all these nails become what? Magnets. So you end up with a chain, and this is what we call a magnetic chain. Now, next, in Roman 2, we are supposed to define the word magnetic induction. Magnetic induction is related to what exactly we have just discussed. You see, let's go back to the diagram here. When you bring a steel bar near a bar magnet, what happens? It gets what? Attracted. That process is what we call magnetic what? Induction. A process where a ferromagnetic substance like steel, iron. When I say ferromagnetic substance, I mean a substance which can easily be attracted by a magnet. So a process where a ferromagnetic substance gets magnetized when it is brought near a bar magnet. Like this is a ferromagnetic substance. When you bring it near a magnet, it also becomes what? A magnet. You see, it has now got north and what? South. So that process is what we call magnetic induction. So putting it in words, we shall say it is a process by which a ferromagnetic material becomes magnetized when it is brought near a magnet. So once you bring a ferromagnetic material near a magnet, it becomes what? Magnetized. And that process is what we call magnetic induction. A process where a ferromagnetic material becomes magnetized when you bring it near a magnet. That process is called magnetic induction.